In this short video, we will demonstrate how you can reduce your programming time by using the latest feature-based machining technology in NX-CAM. If you face challenges such as long programming times or programming errors on parts with hundreds of similar features, you may be able to gain significant benefits from programming automation. Mold and die tooling structures are typical examples where parts can have many similar features, such as holes and slots. Let's take a look at this mold plate that has many slots, pockets, holes, and corner notch features that need to be programmed and machined. The first step in the process is for the system to recognize the machining features. In an automated process, the 3D geometry that can come from any CAD system is analyzed and checked for feature types. Here we see the system stepping through the recognition process. The system can address a wide range of feature types. The standard system provides more than 70 feature types classified under groups such as holes, slots, notches, and pockets, with the option to add more features that you can define. The system can address complex configurations of the standard features, such as intersecting holes or open pockets. NX-CAM displays the recognized features in the Feature Navigator. You can browse and inspect these from the Navigator or directly on the part. The key attributes of the recognized features, such as location, dimensions, and tolerances, are also displayed in the Navigator. The second stage is the building of the machining process for the recognized features, such as these pockets and slots. In this critical step, the generative feature-based machining in NX automatically determines the best or preferred machining process for each feature. When the system builds the machining sequence, it can also use non-geometric data, such as tolerances and surface finish values. These are typically attached to a 3D CAD part model during the design process. This product and manufacturing information, or PMI, is shown as annotation on the part model and can drive the machining method selection. Let's take a look at the system building the machining process for the features it has recognized. We could generate operations for all the recognized features in one go, but for this example, we will just process the data for these slot and hole features. The system automatically builds the machining process from information maintained in the Machining Knowledge Library. The system considers requirements of this feature and tries to select the operations that are the best fit. It can be set to meet objectives, such as finding the least expensive processes. In this case, the tolerance requirements for this feature that were read from the 3D model force the system to ignore the basic drilling options and select a boring operation. The system proceeds to automatically generate the sequence of operations needed to machine this whole feature. It selects subsequent operations from the library until the process is complete. In this case, 3 operations are needed to make up the machining process. This special method of combining individual operations from the machining library makes the system very flexible. It avoids the need to manage thousands of preset machining method templates. Let's take a look at the automatically generated machining operations in the Operation Navigator. These 2 hole features have the same size and geometry, but one has special tolerance requirements, as shown on the 3D model. The first hole, with no specific tolerance information, has 2 operations in the automatically generated machining process. The second hole is one that has a tighter tolerance and requires a specific finishing process and tool. Thus, the system added the higher precision bore finish operation to the machining process. As we have seen, the feature-based machining in NX-CAM uses a special approach to generate the machining process for each feature from a library of standard operations. This generative approach avoids the need to build and manage a complex set of machining templates, as seen in many systems. In addition, the system allows us to use PMI 3D model data to drive automated NC programming. NXCAM customers report a 90% reduction in programming time using feature-based machining. The feature-based machining capability is included in a number of the standard NXCAM software packages. It is also available as an add-on module.